Morning, everyone.
Morning.
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 Good morning.
All right. So, just wait until a couple minutes. Everyone's starting to come in. All right. So, let's see what we got here. Yes. All right. So right now we have everyone muted. All right. It's just easier that way. So that way background noise just doesn't interfere with everything. If you want to unmute yourself temporarily, you just press the space bar and you press and hold it for the entire time that you want to talk. All right. And then you let go. It takes you off. All right. So that's the other thing. We have chat mentality. So submit those people in. So we have the chat. All right. If you don't have a mic, you can ask questions there. I'll be looking there. I'll try and get there as much as I can to just be able to look at it. So the other thing that we have to look at is how people want to ask questions. You can ask it in the chat. You can basically, if you scroll down to the bottom of what you have, I can't even just share. Nope. So if you scroll down to the bottom, there's the ability to do reactions. You see a little hand rose in my ability or a thumbs up, stuff like that. Everyone's doing that, which is great. I don't know if it will populate if I have two screens up. So I'm not sure if anybody, let's go Sean Callis. Can you try raising your hand while I'm on the other screen? Can you try raising your hand with the reaction? Or no? That doesn't matter now because you're on my screen with me. So I think once you start to talk, it will populate and bring you up to my screen because I can only see about 20 of you at a time. If anybody is seeing someone that's in the waiting room that you are all in, let me know, and I'll admit them as fast as possible. I don't want to keep them out from here. Now, if you have a question and I'm not seeing you raise your hand or anything like that, just unmute yourself and try and just be like, I have a question or anything like that. We did it with the other class. It's really not that bad. You don't have to sit there and, raise your hand or whatever on the screen. So 2 things. 1, I'm going to be recording all these lessons. So you're going to see them up on YouTube. All right. I'm going to make a YouTube channel that's not my personal one. It's just going to be based off of my old professional email that I have through Gmail. So I'm going to post the lessons there. So that way, if you guys have a bad internet connection that cuts out or anything else like that, you can rewatch it. All right. I'm going to be emailing out the link to it. So that way you guys can get it. I haven't set it up yet because I only have one class that recorded and it literally just popped up saying it was done, saving it in a format that I can upload. Number 2, going through with this, you guys have the ability to go through chat. You can chat other people in the class. All right. So just be aware that you know, if you're sending it to the group or if you're sending it to one person, just be aware of who you're sending it to. All right. Now let's see. If you look at your Zoom invitation, let's see where we got. Share the screen. So if you look at your Zoom invitation here that I have right here that I sent you all, this is for the 10 o'clock class. It's going to be the same link. So this link right here is going to be the same one every single week, every single day that you have for the class. All right. If you want to be able to see the entire lesson and you want to be able to call in, you can call in here if you're in New York, if you're Chicago, everywhere else. So you can actually dial in. And if you don't have like a microphone or anything like that, and you want to be able to ask questions that way and not have to type it out into the chat, you can also just call in and it won't ring. It's not going to be like a group voicemail or anything like that that's going to come in. You're just going to come in normally. So you have the ability to do that. All right. So, but if you do that, just do it earlier on in the presentation because you would still be stuck in the meeting room, the waiting room. So. All right. So that is really it on the Zoom. A couple of things as far as questions that I was seeing. Let me pull up the questions. Okay. Everyone who did the Microsoft Forms, I appreciate it because that just gave me a good idea, like a good all around of what to expect from you guys. Let me know if you guys are going to be contacting each other more than I will. So if anybody is actually seeing, if they know one of their friends that does not have any access to internet, they're, try and reach out to them. You're going to find out faster than I will at this point. All right. Let me know about that. Obviously, no one answered, no, I don't have internet when they didn't have internet to answer my poll. So good job on that. All right, so a couple questions that I know some people ask me. Internet coming in and out, as long as you log in, the attendance are going to be taken via the Zoom chat. So as you log in, that's how I'm going to be taking attendance with it. All right, just like if you were in class. So that's how we're going to be doing this. The other thing that we're going to be seeing is that I'll have the YouTube channel, so that way if it blocks out, you guys will have it. I spent as much time that I could last week and the weekend going into it to basically get the best stream as possible for you guys. So I ran Cat 6 cable in my house, so that way I can actually output a really good stream. Other than that, it's been good microphones and good cameras. I don't have either one of those that came along with my work laptop, so my work laptop's like over there somewhere. Now let's see. So with labs, right now, labs are obviously not happening because no one is here who's going to be on the ship. So you guys are basically, a couple things are being floated around about this. You can have, we might be doing something where you come in 2 weeks after finals week, and that will be 2 weeks straight of 540 lab and any other ship lab systems that we're going to be doing. Because usually what would happen is, what happens on a normal school year is you have finals week, you have a week of pre-cruise, and then that Sunday after pre-cruise, you basically get on the ship and you go out for the summer. All right. So we have finals week. There might be 2 weeks of something like the 540 lab happening. We're not 100% certain. All right. So I know international students have been told that they are not going to have to come back to campus. to basically, it's not like, April 4th, we're going to open up the campus again. All right. This is their new reality we're going to have all the way through finals week. This is how we're going to finish out the school year. As far as what cruise is going, as I've been telling the last class, that's way above my pay grade. If you think I have the ability to change cruise, no. I don't have any control over that. We're going to see how it goes. The same advice I sold to the other class. Take it like INDOC. Whatever's happening the new day, just roll with it. All right? Don't worry about 2 days from now. Worry about what the information you have at this moment and go off of that. All right? And that just goes for what we're doing in the school year and as we go through this entire new way of going through basically life. So that being said, any questions as far as what we have with anything going on, you can just unmute yourself and ask it. And I'm going to go over grading in a second.
What are we going to do about tests and exams?
Okay. So with exams and tests and quizzes and grading, which I'm sure you're all very curious about, is we have one test left. We have exam 3. All right. Exam 3 is going to be hydraulics and electricity. Now, okay, another person to be admitted. Now, we are going to have an open notes exam. All right. Because at this point, there is no way to see and stop any cheating that may happen. And you know what? We're just going to open the floodgates to any issues with that. All right. That being said, these are still going to be timed. It's not like you're going to give you 3 days to do an open exam test. All right. So basically, if you have older brothers, older sisters that went to this school, or parents that are, a chief engineer, don't be utilizing their resources. Don't use someone else to take the exam for you. We're going to be having it still during class. It's going to be an online examination. So Zoom's going to be open on your computer while you're going to be, or on your phone pointed at you while you're going to be basically taking this exam on Blackboard. Extra time, stuff like that is going to be dealt with at that time period, but I can open it up and keep it open longer for other people. That can be done. Now, so that's exam 3. So, and just no YouTube videos. So just no outside sources, no YouTube. So just your notes and the slideshows. All right. So let's just try and keep it to that. It's basically going to be the honor system. All right. So that's exam 3. The final, I'm going back and forth on how I'm going to do it. This class has 54. The other class has 67. The final, I'm not obviously going to have you guys come into the school. We're on mandatory lockdown in New York State, or shelter at home. I'm sure a lot of you are aware of that. I can't even go back to the office. I literally went and grabbed all of my binders and books on Saturday. I went into the school and grabbed it all. So make sure you guys just keep an ear out. I might do an examination, and I may do a one-on-one, more or less of a Q. So it's going to be like 5 minutes, tell me everything you know about valves. 5 minutes, tell me everything you know about an evap or the steering gear system, or I'm going to give you a list of topics and I'm going to choose one at random and you're going to tell me everything you know about it in 5 minutes. All right. That may I may do it that way. I may do it just the basic, 100 question test. We'll see how we go with it. And which way I'm feeling about going with our examinations. Now, today we have no quiz. I know when we left the school, I was saying every single time we come in, expect a quiz. Today, I was not going to have a quiz because the ability for us to understand how we're going to do it would not be there, and I wouldn't expect anybody to freak out about how we're going to do it. But come Wednesday, come next Monday, come the Wednesday after, we're going to still have quizzes. All right. So the way we're going to do quizzes is log on to Zoom. All right. So we're going to log in just like normal we have. When you take the test, you have to have our cameras on. Yeah, you're going to have the cameras on if you have that ability. All right. If not, we're going to have the microphones basically on so that way you're not asking. The other thing, so with quizzes, we're going to have them on Blackboard. I'm almost certain we're going to have them on Blackboard. Look out for an email. It will determine and basically describe everything that we're going to have. So it's going to be like a 10-minute quiz, 10 questions. It's going to be just basically what we went over. So today what we're going to do is review steering gear because it's been a week. All right. Come Wednesday, we're going to have a steering gear quiz. And then the quizzes are going to stay up on Blackboard so you can utilize them to study. And that way you can use them to study for the examination as well. All right. So exam 3 is going to be hydraulics 1, 2, and 3, and it's going to be all of electricity. All right. Unfortunately, the week that we had off was our week of review that we were going to utilize for our finals, and we're not going to lose any material. We're just losing time at this point. All right. Anybody have any questions?
For like the lab, you said, does that mean that we still have to hand in our labs to you or like take a picture?
No, we're not going to be grading. So thank you. That 10% that was going to be your lab notebooks, I'm just getting rid of that. It's going to be 10% of attendance, 10% participation, kind of like high school mentality. All right. So that's the what we're going to be basically getting for those 10%. I don't feel like throwing it into that. Any other questions? Nope, we're good. Okay.
There's a question in the chat.
How do I participate on Zoom? Just by doing that. Basically just being here, asking questions, just being a part of how we go through a class and everything else like that. I'm not looking for people to ask questions, and it's not like I'm going to be sitting here with a little pen and, okay, this person wrote 10, or, ask the question and they get 10 points for the day. Just being a part of what we're doing. All right. And if people see a question on Zoom, question in the group chat that I'm not recognizing, it's just because I'm still getting used to this. I'm not a Twitch streamer. So do exactly that. If you see something, let me know. All right. So any other questions about what's happening, anything in the school, how you guys are being contacted, how the Zoom is working out, anything like that? Everybody good? All right. So let's get going into basically a review of steering gear. There we go. All righty then. Let me just pull up the chat. So, steering gear. All right. Steering gear, we have our rudder. We have our rudder stock. We have our tiller. We have our steering gear pumps, our 6-way valve, and our rams. All right. Big thing here. With our 6-way valve, this only controls which steering gear pump is online. It does not control the flow of which way the rams go. All right. They only control where the flow is coming from and where it is going to. So the rudder is moved by what's called the Rapson slide. All right. The rudder is moved by these rams. So if you turn it to starboard, this is the Rapson slide that's actually happening. All right. This is basically a cube that sits on top of the slide, on top of the ram itself. And the Rapson slide is hugging it basically on either side. There's no gears internal of it. There's nothing in here that's doing any sort of gearing. It is basically a metal on metal that's going to be sliding across on itself. So if you're moving the rams are going to be moved by our steering gear pumps. All right. So we have a starboard discharge right now. And with that starboard discharge, we are not only just pumping hydraulic fluid into here and into here, but we're sucking out hydraulic fluid on the opposite side of the rams. And they're going through and going into these cylinders and pushing the rams in opposite directions. All right. So now basically our rudder would look like this in this position of what we see here. All right. So if we have a port discharge, the opposite is what's going to be happening. Will I make the PowerPoints available on Blackboard? Yeah, so I'm still going to do the same thing. PowerPoint's going to be on Blackboard. I'm even going to put them up before class as well. So that way you don't have to have the video stream up if you don't need to, but I'm going to be putting a lot of information on, like I have been already, up onto the PowerPoint. All right. So remember, we have our actual pump. It's always spinning. All right. And the tilt plate right here, this tilt plate is what's going to be controlling the flow. So we still have all of our little pistons inside of here going up and down. All right. The tilt plate is in its neutral position. You're going to have no flow going out. As soon as that tilt plate moves, now we have actual movement. Now we have movement on the tilt plate. We have flow going through, and now our rudder down here is what is actually going to be moving. All right. Same thing again, the tilt plate moves, and now our rudder moves. So the six-way valve. Like I said, the six-way valve, all it's doing, this entire job, is to determine which pump is online. All right, so we have a starboard and we have a port. So in this configuration with this six-way valve, which one is online, which one is on standby? If you know, just unmute yourself and say it to the group.
Starboard's online.
The starboard is online. All right, and we can tell because we can trace out these lines and as they go into the rams. All right, and the port one is just recirculating itself. So the starboard pump is online and the port pump is either on standby or it's running, but it's not actually producing flow to go to the rams. All right, it's just recirculating itself. Now, the big thing is like what we talked about 2 weeks ago. These tilt plates right here and right here are both going to be operated. All right, the yoke from the differential is going to be tilting both of them at the same time. But because of the six-way valve, only one of them is actually going to be sending fluid to the rams themselves. So we have flow going. Our tilt plate has moved. And as you can see, only the starboard pump is actually going to be influencing which way the rams are going. The port pump is just recirculating. We come back to neutral, and the rams are hydraulically locked at that position. We go the opposite direction. It still does not matter. The port pump is still on standby. All right, and now we have switched, and our six-way valve is now going to, the port pump is now online, and the starboard pump is now on standby. It's recirculating right here. The same thing again. It has complete control over which pump is going to be the one that's actually influencing our rams. So we have three positions, even though it's called a six-way valve. The six-way valve is called a six-way valve because we have the 6 ways fluid can be actually going. All right. So we have our starboard pump online. We have our port pump on standby. The second position is the port pump online and the starboard pump in standby. And the third position is where it's locked. The rudder is hydraulically locked. There's no fluid going to be flowing in any direction. All right. We would use this when we're in shipyard and we're in dry dock and we need to do something with the main shaft if we're trying to pull it out, or if we're doing some work on the rudder itself. We want to basically dead stick our ship, which is basically we have no power on the ship, and we're basically going up like the Hudson or something like that. And the what do you call it? And basically tugs want to have full control. All right, and predictability. We don't want the rudder to just be going off and doing whatever it wants. All right. So does that mean that we don't need to change valves to relocate our rudder? What do you mean by that? Previous page. So remember, this is a 6-way valve. It's going to be spinning on an axis. All right. It spins in a direction either this way or that way. All right. And as it spins, it's going to choose which way the flow is going to be going. So in order to, we don't have to actually, if we have our rudder here, all right, in order to change the direction, we don't change our 6-way valve's position. The port pump, well, this is a starboard, and port. The port pump doesn't make the rudder go to the port direction. And the same thing with the starboard. The starboard pump does not make the pump go to the starboard direction. All right. So the 6-way valve does not. It does not control the position of the rudder. The 6-way valve only controls which pump is online. The tilt plate controls the flow. Aren't the Rams hydraulic? Okay. So the third position, is if, like I said, you don't have power. You don't want to have, if you are trying to lock it, it's not going to be utilized during normal procedures. You're not going to be locking the rudder when you're going across the Atlantic or anything like that. This is when you're going to be in emergency situations. It's going to be when you are allowing tugboats to have full control over you. If you don't have power, if you have a leak on one side or the other. So if any movement of your, say if you're, so if you have a leak coming out of your rudder stock with any movement that you have, that's when you would want to have your six-way valve locked. So that way you don't have any movement coming in. All right. Remember, your tilt plates, both these tilt plates, control the flow of hydraulic oil. All right. So if your tilt plate is going to be in this direction, you have hydraulic flow going through in that orientation. So your port pump is what's actually controlling the flow going to your ramps. Your starboard pump is just recirculating itself. All right. And if your tilt plates go the opposite direction, then your flow is going to be the opposite way. So your six-way valve only controls which pump is online, not which way your ram is going. Right? So rudder locked is going to be like an emergency situation. It's going to be if you want to be dead sticking, which is when you have no power on the vessel and tugs are going to be pulling you, to the boneyard or to the scrapyard to make the ship razor blades, or if you have, if you just came out of dry dock, anything like that. How's the rudder lock pumps offline different? All right. So anybody have any questions on that?
Is there any significance to having one pump on and not the other? Like, will the port pump make me turn faster towards the port side, or no?
No, it'll have no difference for what's going on. It's basically a backup. All right. So if you, like we have with anything, like we talked about in class, like if you have a lead lag scenario, this wouldn't be a lead lag scenario. This would be, you have your port pump online, starboard is on backup. All right. So if you're going through Hell's Gate, you don't want to have a pump that's going to go offline all of a sudden and have no ability to go through steering. All right. You'd only want to be able to just change over your six-way valve really quick. And then now you have steering back. All right. These are just backup scenarios, basically weekly or monthly, depending on what ship you go onto. Your pumps will be changed over. So we're going to go to starboard this week. Okay, next week we're going to go to port pump. And you just basically go back and forth. All right. Any other questions? All right, so we all understand that the six-way valve controls which pump is online. It does not control the direction of the rams. And the way we have to think about this is, yes, just because you can have them hydraulically locked when the tilt plates are neutral doesn't mean that you don't want to discount for like any sort of scenario. You always want to basically cover yourself whenever you can. That's why we have lockout tagout with our electricity. We'll get into that. All right. If you're going to go work on something electrical wise, you just don't go, oh, it's off. You disconnect the power and you put a lock on it and you ensure that there's going to be no issues with it. All right. It's the same thing with if you guys are going to be working on a lawnmower. You take out the spark plug before you do it. You're ensuring that there is no possibility of that lawnmower starting up. All right. And guys, like I said, I've worked in a shipyard. If you think something can't happen, it will happen, and you will fall behind because of it, or people will get hurt, or whatever. Something will always happen, and it's probably not the thing you want it to be. Okay. Negative feedback. All right. Like we said in class with this is what you want. This is what you have. All right. And that's what this is what you have left. All right. So what you want, what you have. So what we're trying to do here is your want is just like we have. If you're having a recipe that calls for 10 apples, all right? So you want 10 apples. What you have in your cart at that moment when you reach the apple bin and you're in the grocery store is 0. So 10 minus 0 is you still need 10 apples. All right? So now you still want 10 apples. What you have at that moment is 1 apple. So now your error is 9 apples. All right? And that's constantly happening when you have negative feedback. All right? You're not sitting there and you're doing this basically naturally. You're not going, oh, I need 10 apples. Oh, I need 10 apples. Oh, I need 10 apples. And counting up to 10 every single time. You're basically grabbing an apple out of the cart. Okay, now I need 8, 7, 6, 5, as you go through with it. All right, that's a negative feedback loop. So we have the differential gear. All right, we have 2 inputs and 1 output with a differential gear. Input gear number 1. This is coming from the helm. This is coming from the rack. All right, the rack is controlled by the helm. So over here is the rack. I know I did double R. All right, where over here is the rudder. All right, whereas the rack, this is our want. And this is our have. So we want 10 apples. And we have, right now, we have 2 apples. So our output, coming out on our output, means that we have 8. We still need 8. All right? So this is our want. And this is our have. So as these turn with a differential, when you guys had your last, lab, a lot of people learned about the spider legs. All right, the spider legs are what's come off of this yoke. So they go up and they go out and they go right to the tilt plate. All right, and that's what you're seeing as far as the movement is coming from these yokes. So that's a laser pointer, that's not a pen. This yoke is controlled basically by these input gears. So if you were to take your right hand and your left hand, you basically try and put them together like this, all right? And if you turn one hand or the other, it's going to force based on each force that's happening with those gears. It's pulling it, all right? And you could feel one hand having to go into an opposite direction in order to basically allow you to move, all right? So your left hand down here is your input gear. Your right hand up here is going to be the output. If you start spinning this input, it's forcing your other hand to go in that direction, all right? And that's what's happening with here. These gears right here and right here are forcing this yoke to move because it has nowhere else to go. They are geared together. Each gear is applying a force on that gear tooth. All right? And that gear tooth has nowhere else to go, so it has to go in the only direction it can, which basically is to spin. And in turn, it's going to spin this yoke. Okay? Now, this input gear coming in here is what we have at that moment. That is coming from our rudder. All right? And that's what's causing our negative feedback loop. It's what we want. This is what we have at this moment. And what it's coming together is what's telling to our tilt plate. All right? So the blue arrow itself, that is going to be our want or our helm. Our yellow and red. And that is what we have. And that is our rudder. All right. So as the blue arrow is moving, that is coming from our helm. All right, it has moved the yoke. And now watch this with new eyes as you go through with this. All right, watch that again. We want to turn to starboard. All right, the yoke is turning. Great, great, great. We are having as our feedback comes in, watch the yellow and how it corresponds to what's happening with our yoke. All right. We are having an input put in. We want 10 apples here. All right, we have 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. We are now at what we actually have achieved. All right, and that is why every single time as we go through, we are having less and less and less need to be on like an on-stroke mentality. All right, does this differential make sense? More sense than what we were seeing last time? Doing good? Okay. Any questions on the differential before we continue to go through with the rest of today's lesson? Nope? Okay. So same thing as we go back. So we're on stroke. We're going to starboard. The yoke is changing our tilt plate. We have a matching, basically the rudder matches. That input comes back in. Now we want to go back to center. So now we're going to have a stroke that's going to port. So now it's moving all of it back the opposite direction. So what turns the input gears? All right, so we have two things. Input gear number 2 is coming from the rudder, and input gear number 1 is coming from the rack. Does this change for different types of steering? What do you mean by that?
Like if it's follow-up or non-follow-up.
Okay, so if we, all right. Like you're talking about different vessels or?
Like if it's the wheel or the stick.
Oh, so if you have like a joystick that you're using, whereas if you have a rudder, let's just keep to a steering wheel itself at this point. All right. If you were to utilize a stick, it would have the same idea, but just keep an idea that we're going to stick with just a helm itself. Okay. And not go to basically a rudder. Like if you think of a joystick in that mentality, it's just going to get confusing as far as where we're going. All right, it will still have the same effect of what we're doing, but it just gets a little bit more convoluted to understand. All right, stick around at the end of the lesson. We can go over that if you want to. All right. So with input gears, we have input gear number 2, and this is input gear number 1. Right here is our differential. All right, and coming out is our yoke. All right, that's our output. So we have what's called the rack and the rack's position. And the rack is basically an entire gear just opened up. All right, so there's all these teeth all along it. And a position on the rack is a direct indicator for what you want to do with the rudder. All right, so you will have your 0, and that will be the center line of the ship. All right, you'll have a 5 degree, you'll have a 10 degree, and you'll have all the little lines. It will basically look like a tape measure on there. All right, now this right here, this shaft coming out is going to be a gear. All right, as I show off my drawing abilities of a gear. Now, this is going to be spun. All right, this gear right here is laying on top of the rack. All right, so this gear is going to be spun by the direction of which way the rack goes. And there was a question here, when the yellow arrow turns, is that desired? We have reached the desired rudder angle. Yeah. So when the yellow arrow is turning, that is basically what is coming back in from the rudder. So it's basically what's happening is we are at the blue arrow on the last screen as we go back. So as the blue arrow turns, that is what's happening. That's coming in from the rack. That is what we want. And as the yellow arrow is turning, so say it was like here, halfway, that means that the rudder is in its halfway position to what we want. All right. And if you notice the yoke, watch the yoke as the yellow comes back. All right. The yoke is slowly turning back and it goes to its neutral position. And as soon as the two arrows meet and come together, that is when we are now on a 0 stroke. All right. We are in a neutral position. We are no longer having any flow going through our hydraulic pump. All right. So we have our rudder position. Let me delete some of this nonsense. So we have our rudder position, we have our rack position, we have our tilt box. This goes directly out to our tilt box. All right, this is the yoke, like I said. So whichever way that the rack goes, that is going to be directly going to be affecting which way the rudder is going to be turning. Can you explain what the yellow does again? That yellow arrow is what's coming in. So the yellow arrow is what's coming in from the rudder. All right, that is our input. That is our basically our negative feedback. That's how many apples we have in our cart presently. All right. So the yellow arrow is what we have at that moment. All right. Whether it's we want to go to 10 degrees right rudder, that means while it's moving, and we want to go to 10 degrees right rudder, we move and we're going, okay, now we're at 1 degree right rudder. So the yellow is saying, okay, we have 1. All right. And as it continues down that line until it reaches 10, it's going to be saying, we still don't have what you're telling me we need to have. Okay. Does that make sense? Okay. Oh, that's the one thing did I mention how office hours are going to work? Okay, so just like what we have for this class, this, and I explained in the email, that link is going to be what you're going to need to sign into this class every single Monday and Wednesday for the rest of the time we have for this semester. I'm going to have open office hours, and this is going to be my office, and basically I'm going to have a Zoom conference that's open. All right, it's going to be the same link every single time for my office hours. It's going to be basically said like, oh, from Tuesday from 9 till 10, I have office hours. That's not the office hours, but basically I'm going to have more office hours for you guys because I'm going to be home and I don't have to worry about commuting. So Tuesdays and Thursdays, I'm going to have more office hours for you guys, and basically come into the Zoom and start asking me basically like, hey, can you hear me kind of thing. I'm going to have it the ability for you guys to have it unmuted. I'm probably gonna have it up in the background. I'll be doing other work. All right. So that's how the office hours are gonna be working. All right. So now we're gonna go through what actually moves the rack. All right. The rack is moved via hydraulics. All right. We have this pilot pump. This pilot pump is going to be spinning at all times. All right. It's not going to not be spinning. We have 3 positions with the shuttle valve. We have a normal flow right here. We have a reverse flow, and we have a recirculating. All right. So as the pilot pump is always pumping, when we have our steering gear system up, we are going to be in one position or the other. If we're in this position, we have a straight flow. We can see hydraulic oil comes through and it comes onto this side, and we have pushed the rack this direction. All right. Now, if we go the other way, we have a cross flow. That means we are now pushing on this side and sucking from the other side. All right. This side was pushed and this side had flow that was getting sucked out of it. Now, what controls the shuttle valve? The shuttle valve is directly controlled via the bridge. All right. This is where the helm sends the signal. All right. Over here is a solenoid valve, and over here is a solenoid valve. All right. Now, they're basically magnets. All right. They're electrically coiled wire with a magnet in the middle. And that magnet in the middle are these poles. All right. So when the solenoid is energized, you can see it pulls in the magnet. All right. And vice versa. So we have, like I talked in class, we have 2 different types of solenoid valves. We have a normally open and a normally closed solenoid valve. A normally open solenoid valve is when it's de-energized, the magnet is normally pulled into the coil. My fingers are the coil, and this is the magnet. It's going to be pulled into it. Normally open when it's no electricity flowing through the wires. Normally closed is the opposite. If there's no electricity, magnet is pushed out. All right. Now, both of these are done for safety. So where normally open, just like when we were talking about when we were making water, if you were to lose electricity, all right, you would not want to send salt water to your distillate tanks. All right. So a normally open valve would not be utilized on the valve that goes to your distillate tanks. All right. It would be utilized as your dump valve. So if you lose electricity, water would flow and then flow and dump. All right. Now, the valve that would protect your distillate tanks would be a normally closed. So if there's no electricity, it's stopped and no water will flow into it because it's a normally closed position. So right now, we are in a normally closed position on both solenoids. All right. So we have a signal that comes from the bridge. This solenoid here is energized, and now we have flow, and it's moving the rack. All right. The rack is still over here. We still have the piston, and this side is still the pilot valve. All right. It de-energizes. We have no flow. It is still recirculating, all right, through the pilot valve, but the rack has not moved. All right. We want to go in the opposite direction. We are now going with a cross flow, and our rack is getting flow. The piston is moving, and the pilot valve is still having flow going through it. All right. So how are the solenoids energized? This is what we didn't get to last class. So when you turn the steering wheel, you are going to be generating an electrical signal. So when you turn to port, you are going to generate a positive voltage. The more you turn to port, the greater the voltage is. All right, so they're proportional. And that goes again, if you have less of a turn to port, it's going to be a lesser voltage. Now, when you go to starboard, you are going to have a negative voltage. And the same thing again, it's proportional. The more you turn to starboard, the greater the negative voltage is going to be. And now you can see the rack moves to port, generates a positive voltage. The more it turns basically the more it turns, the more and the greater you're going to have. All right, they're both proportional to each other. All right. We'll get back into this when we do electrical, but for right now, we're not going to deal with this for right now. So these couple slides skip when you're doing your own review. So we have our helm position and we have our rack position. All right, we have our difference. Kind of the same thought as our have and our want. So the helm position goes to port. All right, so we have a positive voltage. All right, so it sucks in on this side. All right, when the helm position equals the rack position, now we have a difference of 0. So we go into a neutral. So now we're just going to be flowing back to our pilot valve. All right, and then the opposite is true. When we go to starboard, you're going to have a negative, because the helm has a negative voltage. The rack position has not met that negative voltage. All right? It has not equaled it to create 0. All right? And as soon as it does, we go to a 0 position, but our rack has not moved past that. All right? Just because we have a 0 differential doesn't mean that the rack has now moved back to the 0 point. It just means that both the helm and the rack are both in the same position. Okay? So if we want 10 degrees starboard, until we achieve 10 degrees position on our rack, remember I told the rack has different markings on it. So it has a -10, -5, a 0, a 5, a 10. All right? If we want a -10, until our rack hits that -10, our differential will not be 0. And thus, we will still have one of these solenoid valves sucked in and creating flow until that rack has moved to the position that we want it to be in. And then we will have a 0 condition, whereas the solenoid valve will be de-energized. The rack stays in the position that it needs to be because that's the only way we will have a 0 condition, and we're good. All right, does that make sense? Does anybody have any questions on it? Okay. Take your eerie silence as a yes. So as we go through the steering sequence, there's almost 2 parts to it. All right. Part 1, as we go through, you have your steering gear pump running on off stroke. So the tilt plate is in the neutral position. All right. The pilot pump is running. It's recirculating right now. We are not having any flow going to the rack. So the helm calls for right rudder. The starboard solenoid valve energizes. The shuttle valve position directs the pilot pump and discharges to the rack piston. So that whole entire evolution we just talked about with our solenoid. The starboard solenoid is energized. We now have flow going through to our rack, and it's pushing our rack. All right. And as soon as the two meet and have a zero differential, that starboard solenoid valve will de-energize and bring it back into the neutral position. And the rack will stay in the position it was affixed at. So the rack moves to starboard, turning the differential gear number 1. So this is the position that's coming from the helm, from the rack. So the rack movement matches the helm position. All right, it de-energizes the solenoid and returning the shuttle valve to the neutral position. So now we have no flow coming out of that pilot. All right, it's just recirculating. All right, so this is what it is in image. All right, it's going to use numbers. Unfortunately, it doesn't have numbers here. All right, so number 1, this is our steering gear pump. It is just moving, not circulating any hydraulic oil. All right, here's our pilot pump. Again, it's just moving. It's not circulating anything. When I say it's not circulating, it's not going to our rams and it's not going to our pistons. It's just recirculating the flow. We turn our helm to starboard. Turning our helm to starboard, we are now going to get movement. All right, our shuttle valve moves. The solenoid valve sucks it in. All right, we now have flow. Our pilot piston comes up, so all of that flow comes in here. All of the hydraulic oil gets sucked out. All right, we meet whatever order we wanted. All right, if we wanted 10 degrees right rudder, as soon as this reads 10 degrees right rudder, we send a signal out to our shuttle valve and says, hey, it's the same as what we wanted. It's 0. De-energize our solenoid valve, and now we are just going to be recirculating here. All right. But just like what's happening in our differential gear, as soon as we have movement on this rack, we are getting input going into our differential. We now have movement going into our differential, which means that our tilt plate will start to move. All right. So we have now moved on the rack. The rack has now given an input. The differential gear output puts steering pump on stroke. So the steering pump tilt plate has now moved. The rams driven by the steering pump discharge. So they are either getting moved one direction or the other. The rudder begins to move to starboard. Rudder motion transmitted to differential gear input number 2. Differential gear output takes steering pump off stroke. The rudder motion stops. Next helm movement will restart sequence. So we're going through. Like I said, as soon as this moves, it's going to be inputting and it's going to be changing our differential. And our tilt plate is going to move. So now we are going to have flow going through and going to our rams. Our rams move, causing with the Rapson slide, it's going to move our rudder. Our rudder goes and says, hey, we are now at 10 degrees or we were at 8 degrees and we have our negative feedback. So it feedbacks to the differential. The differential says, okay, we're good. We're meeting what we want to be at. And it changes the tilt plate back to neutral. All right. And again, if you want to restart this at any point, if you're sitting at 10 degrees and you're thinking that's not enough, we need to go to 15, you don't have to wait for this entire sequence to be over before you can start putting more input. You can change this at any point. All right. So if you steer and you go, oh, I want 10 degrees. And then you realize 10 degrees is too much even when you hit 8, you can change it and change your input to 5. And it can stop this at any point. All right. Or if you realize 10 isn't enough and you need to go to 15. All right. You can change it at any point. You don't have to wait for the sequence to be over before you continue on. It's just like steering a car. So that is it as far as steering gear itself. You guys have any questions on it? Does it make more sense than what was happening last class? Okay, good. So remember, we have a quiz come Wednesday. Make sure you log into Blackboard. All right. The quiz will start when classes start. You will have to, basically, you'll have like 10 minutes to do the 10 questions. Log into Zoom like you guys did this time. Really good as far as, getting in here like 5 minutes so we can start class really quick. If anybody has any general questions, I'll stick around for a couple minutes. Otherwise, you guys are good to go. All right. Have a good rest of your day. If anybody has to still take, don't leave yet. I forgot almost to let you know this. That's things. So really quick, this book right here, Ugly's Digital Reference. All right. This book is really, really good. And since we're going to be getting into electricity in basically next week, this book is one of the best books out there for just general electricity as far as we're all training to be operators. That's what this does really well. First chapter it goes into, it just goes right into Ohm's law. All right. Now, the big thing that I find that's really nice about this is that it gets into what operators need to know and the theory behind it, which is the smart way that what makes us and going to college for this and not just going and being a house piper with this makes us really good at is learning this is a motor controller. All right. That's a wiring diagram for it. And we're going to be getting into that in a week or so. All right. And this does a very good job of explaining it pretty much on any merchant book, any merchant ship that you go onto. Someone will have a copy of this. Usually they'll just be sitting in the control room of the vessel that you're on. They're that good that people just buy them for themselves. It's $12 off Amazon. It came in like a couple days for me. I will post the link onto Blackboard so that way you guys can do it. All right. But the nice thing is that they have the Ugly's electrical reference. They have motors and controllers. They have really residential wiring, anything that has to do with electricity. They have it, but this is just the general electrical reference. All right. So not mandatory by any means, but if you know that you're a little confused by electricity already, it might not be a bad thing to pick up. All right. What's the name of the book again? Ugly's electrical reference that I literally just sent to one person. You know what? We'll do this. Again, I will place out an email with the link to the YouTube channel. So that way you guys can actually get to it easily. Like I said, that's not going to be your attendance as far as like, oh, I watched the video. All right. You do your best to get here for these classes. We need to do that for STCW. All right. That's the link to it on Amazon. You can find them secondhand, but this is the 2020 edition. It's $12. I can't see these being much cheaper. Unless you find them for pennies. All right. So that is it for you guys for class. If you guys have any extra questions or you want to stick around, I'll stick around for a few minutes. All right.